Alright guys, welcome to Statistics Chapter 3, Section 3. We're talking about percentiles and box and whisker plots today. So, to start off, we're going to talk about what a percentile is. You've likely heard this term quite a bit in the past. If you talk about like SAT scores or any kind of big standardized test, they'll typically say, hey, you're in the whatever percentile. Now, what that means is if I'm in the 80th percentile, then I scored at or above 80% of people. Okay, so another way of thinking that is, so in my example here, the 85th percentile means that 85% of the overall data is going to be at or below what my value was, and that equivalently means that the other 15% is going to be equal to or above where I'm at. There's the kind of equal to on both sides there because it's a little bit ambiguous as to how many people are exactly the same as like you, so we kind of leave it in that kind of space there. So go ahead and try and answer these questions, A and B, or I guess they're labeled A and A for some reason, but try and answer those and see what you can do and then come back here. Okay, so we should again, it just means that, hey, 89% of other people scored lower than you. And the percentile doesn't mean you scored that well on the test, right? If a test is extremely hard, right, and you score a 12 out of 100 on it, right, you could still have the highest score on it, and then you would be in the 99th percentile or something along those lines. So it does not directly correlate to your grade on the actual exam. It's how you correlate to the comparison of everyone else who took it. Right? So that's kind of how that works and what that means. Okay, so quartiles, these are very closely related to percentiles. They're basically these benchmarks which we kind of set in a list of like data that are certain percentiles. So the first quartile is basically the 25th percentile. The second quartile is the 50th percentile, and the third quartile is the 75th percentile. Now, why they are called quartiles is because, like you're seeing here, they break up our data into equal quarters. So a quarter of the data here, a quarter of the data here, a quarter of the data here, and a quarter of the data here. So we kind of have our lower quarter, our middle lower quarter, our upper middle quarter, and our upper quarter of the data, and we kind of break it up into those different quartiles. So the quartile is just a specific percentile. Like I could say the 25th, the 50th, and the 75th percentiles, and that would mean the exact same thing as we say in the first, second, and third quartiles. What you will also notice is that the second quartile, or the 50th percentile, is effectively your median, which is a thing we figured out how to find a few sections back. So how we find these, first, it's typically easiest to find the second quartile because that's just the median, right? So once you have that, you then want to find the median of the lower half of your data, but you do not include the median or the second quartile in that, right? And then the median of that lower half is your first quartile. The median of that upper half is going to be your third quartile. So basically just cut it in half, then cut each half in half, and that's how you get forest, which makes sense, right? Then the last thing here, the interquartile range. This is also abbreviated as the IQR. Basically, that is the range, but just from your third quartile to your first quartile. So basically what that tells you is here's the range for the middle half of my data. That's kind of a thing which we use to estimate, hey, most things are kind of in this range here, right? And then we get some kind of more outlier data beyond it. But half of our data is here, and then we have the kind of outer half on the extremities. So let's go ahead and try this out. So go ahead and pause the video here and answer A through F and see what you can do. All right, so once we have that, if we order the data, again, that's probably the hardest part of this entire thing. Not that it's difficult, but that it's tedious. We order the data, then if we want to find the median, that is ends up being between these, between these, then we get 221.5, and then we want to say, well, how many values are lower than that? We have having 11 values down on this lower half, and then the middle of this lower half, right? So if it's 11 things, we're looking for the sixth one, right? So 182 is going to be our first quartile. Then the upper half, 1, 2, 3, 4, 5, 6, we're in the middle there at 319. So then for my inner quartile range, I just take that 319 minus the 182 and I get 137 as my inner quartile range. So that's how spread my middle half of the data is. Okay, so a box and whisker plot. This is a graphical way of representing these quartiles, and it really kind of helps to kind of show how spread out things actually are. It's also a graphical representation of what's called a 5-number summary. A 5-number summary is basically your quartiles plus the lowest value and the highest value. So if I had my data here, I would find, hey, what's my lowest number? What's my highest number? What's my second quartile, my first quartile, and my third quartile? If I know all 5 of those things, it gives me a decent idea of kind of how my data is really spread out. So if my lowest value and my first quartile are really close together, I know I have a bit of a crunch there on that end of my values. If they're very, very spread out, I know, hey, I have a really, really wide distribution here. Now, how we can graphically show that is with a box and whisker plot. It's one of those weird things in stats where like the name is this cutesy name that sounds like a 5-year-old girl made it up, but it's what everyone calls it, right? So a box and whisker plot looks like this. We have a box in the middle, and then we have these whiskers on the outer part. Now, all of this really is the 5-number summary kind of graphically represented. So this whisker starts at the minimum, and then we draw it out until we get to the first quartile. Then we have our box around the entire inner quartile range, so from the first quartile to the third one. We draw a line through at the second quartile or the median, and then we have our other whisker that kind of goes from the third quartile out to what that maximum value is. Right. So our procedure for actually creating that, you really want these to have a kind of scale on it. So here it is from 15 to 30. So I can see, hey, my lowest value is at 16. My first quartile is at 18. I have a median at 22. My third quartile is at 26. And then my highest value is here at 28. So this is a pretty evenly spread out distribution here. You'll see ones where it's really where you have a crazy long whisker or a really, really short whisker or a really, really short box, all these different kinds of things. But it really just kind of shows you, hey, here's where all of those particular values are at. So have the actual scale. Then you will typically start by putting a dot at the lowest and the highest values. Then you want to draw the start of your box at your first and your third quartile, then just kind of finish in the top parts of the box. Then typically draw in the median, and then you want to typically draw out your whiskers from where the box ends to where the point for your highest or your lowest values are. And that's all there really is to it. There's not a whole lot more beyond that. You can also see them vertically, as you're going to see here. But as long as you have the scale next to it, it doesn't really matter. So go ahead and pause the video here, try and answer these questions here about these 2 particular box and whisker plots, and we'll come back and talk about it here in a second. Okay, so if we try and estimate the median and extreme values of salaries of alumni that are graduating 2 years ago, so that's this first box here. So our median looks like we're here at about 54,000. Our extreme values, we're kind of bottoming out here at like 43 and maxing out here at that maybe 64. And then our inner quartile range is going to be from here to here, which if we subtract that, is going to be about 7,000, so between 50 and 57. And then down here, doing effectively the same thing for this other set, right? I have a higher median here at 57. I have extreme values way up here at like looks like 68, and then down here at 44-ish, And then if I went from like 60 down to 51, maybe we would have an inner quartile range of like $9,000. So in general, what can we kind of see is the trend here? Well, if they graduated 2 years ago versus 5 years ago, in general, they have higher salaries. So this our kind of median has gone up, but also the spread is a lot wider, right? There's still some that are pretty darn low, but then we have ones that have gone up by quite a bit more too. So, and that should kind of make sense for if you've been working in a job longer, you should be being paid more than someone who has not been working there as long. Okay, so that is it for 3.3. So here is the homework for 3.3, 1 and 2, and then 3 through 11 is just the odds. That also ends the chapter. So our chapter review for chapter 3, which is what we're going to do next, is going to be 1 through 11, the odds. But then this also ends the third chapter in one of our sets. So that means that we're going to do the cumulative review, which is a review of chapters 1, 2, and 3. So we're going to be doing 1 through 18, and that's on page 139. That is going to be your kind of review to get you ready for the test, because we will have a test after this chapter, not a project. So with that, I will talk to you guys next time.